Welcome to The Explainer. Today we're diving straight into one of the absolute biggest headaches in software engineering right now. You know those mind-blowing AI demos we see online all the time? The ones where an agent just flawlessly plans a vacation, codes an entire app, or writes a research paper in 10 seconds flat? Well, what actually happens when you try to deploy those exact same agents into a messy, real-world business environment? Usually, they break. They hallucinate, or they confidently book you a non-refundable flight to literally nowhere. So today, we're bridging that massive gap. We are moving from fragile conceptual AI demos to robust, production-ready agentic systems. We're going to break down the field-tested blueprints that take all that unpredictable AI behavior and actually turn it into reliable, auditable software.
So why exactly do these agents break the second they hit production? Look, if you've tried building one, you already know the pain. You've probably watched your agent get stuck in a runaway loop, just sitting there burning through hundreds of dollars in API tokens in a matter of minutes, stubbornly repeating the exact same failed action over and over again. Or maybe you've dealt with hallucinations where it just completely invents a response out of thin air. Or maybe the whole thing crashes the second an external tool or API goes down. These failures happen for one main reason. We tend to treat agents like magic boxes. But they're not. They are software. And to fix this, we have to start applying rigorous software engineering principles.
All right, here's our blueprint for today. First, moving agents to production. Then, tips for the core layers, followed by evaluation and feedback systems. After that, we'll apply it all by building customer support agents, perfecting RAG agent systems, and finally, engineering deep research agents. Let's get into it.
Starting with Section 1, moving agents to production by embracing modular design.
Okay, to reach actual production reliability, we absolutely have to ditch those monolithic, do-everything bots powered by one massive paragraphs-long prompt. Instead, we need to build modular systems across 5 distinct functional layers. We've got persona, tools and actions, reasoning and planning, knowledge and memory, and evaluation and feedback. Let's kick things off with the first one, the persona layer. The golden rule here, keep the scope narrow. Specialized, single-responsibility agents just drastically outperform broad generalist bots. Plus, they're so much easier to test and optimize for cost. Next up, whenever your agent interacts with other code, you want to force it to use structured outputs. Think JSON or data validation frameworks like Pydantic. Doing this simple step literally eliminates brittle string parsing bugs entirely. You'll also want to inject dynamic instructions, like the current date or specific user info at runtime instead of hard-coding them. But, and this is a big but, be careful not to over-inject. Pumping way too many irrelevant facts into the persona just causes token bloat. It'll absolutely confuse the agent and your responses will suffer.
Moving up to the tools and reasoning layers, we have to build rigorous defenses against failure, because things will fail. You should use hardened, pre-built tools and standard model context protocol, or MCP servers, whenever it makes sense. But remember, APIs go down, databases lock up. You have to plan for this by implementing retries for those quick transient network blips, friendly fallbacks, and strict timeouts so a hanging tool doesn't stall your agent indefinitely. For complex goals, force the agent into what we call a plan, then execute pattern. Make it write out a step-by-step checklist before it takes any action at all. And hey, how do you stop an agent from burning tokens in an infinite loop? You explicitly cap the number of iterations it's allowed to take, hard stop. Finally, add in a quick reflexive self-review pass. Just let the agent double-check its own logic to catch obvious mistakes before it finalizes the output.
Next up is Section 3, evaluation and feedback systems, because we have to measure to improve.
So there is this fundamental engineering rule when building agentic systems. You simply cannot improve or trust a system that you do not rigorously measure. Logging and measuring everything, both internal and external to your agents, is non-negotiable for a production environment. When we look at the ideal data flow here, it's super interesting. Notice that right after an agent generates an output, it doesn't just go straight to the user. No way. It hits an eval and safety gate first. This gate can either pass the output through if it looks good, or if there's a safety failure or even just a low confidence score, it automatically routes it to a human for review. This structure guarantees that guardrails are actively checking responses, meaning your actual users are completely insulated from raw, unchecked, unpredictable AI behavior. To achieve that kind of control, you really need to adopt AI ops. Think of it as DevOps for AI. You have to trace absolutely everything. Record the prompts, log the tool calls, monitor the token counts, track the latency, the whole shebang. You can use built-in SDK dashboards for this or advanced tracing tools like Phoenix to get a global view. And here's a real game changer, automate these evaluations.
You can actually use a smaller, cheaper LLM to act as a judge that instantly grades the main agent's output every time you tweak a prompt. This lets you track accuracy and resolution rates over time without forcing a human to sit there and manually read thousands of logs. But that being said, humans are still your absolute best source of feedback. An effective human-in-the-loop, or HIT-L system, does way more than just catch and stop bad outputs. It captures structured data. Let's say your agent is only about 40% confident on how to process a really complex, weird refund. The system routes that specific edge case to a human reviewer. Then, it captures exactly how the human resolved it and feeds that data back in to optimize the prompt or the tool code for the next time it happens. You're creating a continuous loop of self-improvement for your system.
All right, Section 4, Building Customer Support Agents. Let's see how this looks in a real-world architecture. Let's break down one of the most popular patterns out there right now, the customer support agent. This shows exactly how those 5 theoretical layers we just talked about translate directly into a specific workflow. The persona, that becomes your dedicated support role. The tools layer gets populated with your APIs for account lookups and ticket escalation. The reasoning layer is where the critical triage logic lives. For knowledge, you're using Retrieval Augmented Generation, or RAG, to search over your company's actual manuals. And finally, the evaluation layer relies on those system logs and human-in-the-loop escalations we just covered.
When you're designing this kind of system, keep in mind that the primary goal is really to augment human roles, not just replace everybody outright. The agent effectively acts as a shield. It triages the standard tickets and answers all those basic repetitive questions automatically using RAG. However, the true success of this design hinges entirely on its reasoning layer. The agent has to accurately recognize its own limits, because honestly, there is nothing worse than a bot that traps a frustrated user in an endless automated loop instead of just gracefully escalating the issue to a real human. Being able to identify critical events and seamlessly trigger that escalation is exactly what separates a great agent from a terrible one. Moving into Section 5, Perfecting RAG Agent Systems through Modular Retrieval. So in a RAG system, the retrieval of documents is the engine, sure, but it's the modular agentic control wrapped around it that acts as the steering wheel. That's what adds vital precision, routing, and critique to the whole workflow. A production-ready RAG system doesn't just blindly search. It starts with a triage, or a router agent, that analyzes the actual intent of the user's query to decide if retrieval is even necessary in the first place. Next, a highly specialized retriever fetches the data using metadata filters and hybrid search. Finally, an answerer drafts the response, but, and this is key, a critic agent sits right alongside it to verify the facts. If the drafted answer contradicts the source material, the critic triggers a corrective retrieval. This separation of concerns gives you a massively higher degree of accuracy. But to make all this work smoothly, you have to enforce what we call grounding discipline. This means forcing strict adherence to system prompts like use only the context provided. You should require the agent to generate citations or actual source excerpts for absolutely every single claim it makes, no exceptions. You also need to log your retrieval, recall, and accuracy metrics super closely. And honestly, perhaps most importantly, you have to explicitly train the system to just say, I don't know, when the retrieval comes up empty. Seriously, teaching an AI the very human skill of admitting ignorance is literally the absolute best way to prevent it from confidently feeding your users a hallucinated, completely false answer. And finally, Section 6, Engineering Deep Research Agents. Let's talk iterative planning.
Deep research agents are a massive leap in capability over your standard conversational bots. They mix open-ended web exploration with iterative planning and multi-source synthesis. To pull this off, you need a 2-tier orchestration pattern. Think of it like a manager and their team. At the top, you have a high-level planner agent acting as the brain. It creates the overall research plan. It then delegates very specific tasks down to stateless, specialized worker agents. One worker might search the web, another extracts text from a messy PDF, and another summarizes those findings. You want to keep these workers purely tool-like, meaning no long-term memory. Finally, a critic pass is executed as a last review to check for contradictions, coverage gaps, and missing perspectives before synthesizing that final, comprehensive report.
Now, because these deep research loops can run for a very long time, your control policies are incredibly critical here. You absolutely must forbid the planner from providing direct answers without tool-backed, cited sources. And since deep research inherently takes time, you really need to implement a streaming UX. Show the human user the evolving outline as it's being built. It vastly reduces perceived latency and keeps them engaged instead of wondering if the app just froze. From a cost perspective, cache your repeated queries. It saves time, it saves API tokens. Just make sure you clear those caches periodically so you aren't serving up stale data.
Finally, set strict per-run token budgets and throttle your web calls. You really don't want an agent bankrupting you just because it went down a 3-hour automated rabbit hole on Wikipedia.
So, pulling this all together, if we synthesize everything we've covered today, the ultimate takeaway is this. True engineering is what transforms unpredictable LLM behavior into modular, grounded, and auditable workflows. Production-ready systems do not happen by accident, and they definitely don't happen by writing one massive prompt and just crossing your fingers. They emerge only when you combine tight personas, well-scoped tools guarded by fallbacks, and relentless obsessive measurement paired with human feedback.
So, I'm going to leave you with this final provocative thought to chew on. Take a really hard look at the AI systems you are currently building or deploying right now. Are your agents just impressive but fragile demos? Or have you actually implemented the rigorous architectural blueprints required to make them truly ready for the real world? It's time to build systems we can actually trust. Thanks so much for joining us for this explainer, and we will see you next time.